Tutorials. This is Swastik. We'll be continuing from where we left in the previous video. We have already discussed the different data types and their applications, their programs. Now we'll be focusing on the methods, the operators, the precedences, and the implicit and explicit typecasting. Okay. Methods in Java are of 6 types, similar to the data types, the variables. Now static methods are prefixed with the static keyword. They're part of the Java class, not of the Java object. Non-static methods are part of the Java class. Sorry, they are part of the Java object and not a part of the Java class. This is a flow. Like how do we call a static member from a static member or from a non-static member? How we call a non-static member from a static member or a non-static member? You can pause this video and go through it. I have already discussed the different calling methods in the previous video. Now we'll proceed to the program. I have created two static methods including the main and two non-static methods over here. Simple enough. Now I'm trying to call this static method from one static method from another static method. I can call it in any of the three ways. Here I have called it directly. Here I have called it by the class name, and here I have called it by the object name. You can refer to the table in the previous slide to verify this. Now I'm trying to call this non-static method from this static method over here. I cannot call it directly. I cannot even call it by the class name. However, I can call it by the object name, and that's the only way to call it. You can write these codes and verify. Now, what if I'm calling my caller method is a non-static method. So far my caller method was the main method. From there I was calling. Now what if, and that was static. Now what if I'm calling it through a non-static method? I'm trying to call it the first static method. Okay, let me zoom out a bit. This first method, from this method, I can call it directly, cool. I can call it by the class name, also it will work. I can call it by the object name, also it will work. So far we have seen that to call a static method, we can approach any of the ways, we can follow any of the ways. Now what if I'm calling a non-static method? Say this is my non-static method, I'm calling this from this. Okay, I shouldn't be using this keyword. I'll be discussing that what that exactly is in the further videos. Okay, I can call it directly. This method I can call it directly, but there is a small limitation. To call it directly, both of these methods must be inside the same class, right? Okay. Now there's a general way of calling, that is by the object name. Any non-static method we can call it by the object name. Next we have the final methods. Final, as I have already discussed, final keyword prevents redesigning of something. Like in variables it was preventing making the value of that variable constant. Over here we'll be preventing redesigning of methods. Let's say this is a final method, static final int func. This method cannot be redesigned, or as we'll be studying in the further videos of method overriding, that is a part of the runtime polymorphism. When we'll be studying about method overriding, we'll see that a final method cannot be overridden. Okay. Next, what are abstract methods, native methods, synchronized methods? We'll be requiring some further knowledges regarding inheritance, multi-platform development, and multi-threading. For these three methods, we'll be discussing them as we proceed to those sections. For the time being, I'll be skipping them. But remember, there are these 6 methods present in Java. Now, operators. Operators help us in doing some operations. There are two parts of a function: operands, the values that will be operated on, and the operators, those are the functions that we'll be using. In Java, there are total 44 operators. You can pause this video and note down the operators. There are unary, arithmetic, logical, bitwise, assignment, relational, ternary, special operators. Now these are the operator precedences. Go through this by pausing this video again. These might be required while programming certain specific programs. This is the second set. Okay, now we'll be going to typecasting. Suppose we are trying to convert one data type to another. There are two ways of doing it. One is implicit, second is explicit, right? Implicit is what the system does. Implicit typecasting is done internally. What exactly happens that, okay, let me refer to the slides over here for a better understanding. It converts the lower data types, the value lower data types which have less size, lower as in which have less size, into higher. Let's say I'm trying to convert into a float. It will convert. Okay, I'll give a better example. Let's say I'm trying to convert integer to long. The only reason I didn't explain into float is because they have the same size. I'll be coming to that later. Let's say I'm trying to convert int to long. I need not write any specific code. The Java will automatically do it for me. Let's say I'm writing the code, writing a new Java program for this. Let's say typeconf. Okay, here is my main method. One is int x equals to 4 or 5 and long y equals to 10. I can easily assign y equals to x and then system dot println y. Sorry. Okay, I have to save it in different. It as okay, I have to save it in a different file name. Reason being, I have made it public class, so I have to make it the class name and the file name must be same. Okay, now I'll run it. Compiled fine, no operators. It prints me 5. So y has been reassigned to 5. I have not done nothing, just a simple assigning. This is implicit typecasting. Now, what if I'm trying to do the reverse, trying to convert a long to a int. There I'd be needing explicit typecasting because the compiler will not do the automatic typecasting for me. Now, before proceeding to the ways of doing explicit typecasting, there are the demerits of both. In implicit typecasting, what happens? Suppose I'm converting an integer to a long. The value remains the same, but it takes up extra size. This over here it is 4, over here it is 8. If I'm trying to convert an integer to a long, it will take up extra 4 bytes unnecessarily. That is one demerit of implicit typecasting. In explicit typecasting, there is a chance of data loss. Let's say I'm trying to convert a double value to a float value. There will be loss of some decimal places. Given that, now we'll be proceeding to the different the types of explicit typecasting. How can we do explicit typecasting? Okay, I have taken 3 variables for example. a integer, a double, a string. I'm trying to convert an integer to a double. This can be done directly, no issues. I've just done it in explicit typecasting just to show the different ways. Otherwise, no issues, it can be done directly also. Similarly, let's say I'm trying to convert an integer to a string. I have to use the method value of present inside the string class. It converts a string integer to a string. Next, I'm trying to convert a double to int. Here, implicit typecasting will not work. I have to do it explicitly. I have done it, written int inside the parenthesis, which says the compiler that what data type I'm going to convert. The next one is similar to the previous one, string.value of trying to convert a double to a string. Next, I'm trying to convert a string to an integer. There is a method parseInt present inside integer class which does the same. Similarly, every wrapper class has this kind of method. Like for double, we have parse double. For float, we have parse float, parse long, and similarly. Okay. Now, one more interesting thing that I want to note over here is that I want to show over here is that let's say I'm trying to convert a short variable to a byte variable. That is, short is over here, it takes up 2 bytes. I'm trying to convert it into a byte which takes up 1 byte. So as I said, there will be some data loss. Here the value is 300. When I'm trying to print it, the value of this will come 44. You can run it and see the value will come 44. The reason being, the system does not see the value 300 as 300. It is a combination of binary numbers. And since short takes up 2 bytes, the system, the 300 is stored in 2 bytes of space. Whatever extra value is required to the left, it is padded with zeros. Now, if I'm cutting short the value to 1 byte, it will take up 8 bits. Inside that 8 bits, whatever value of 300 is stored, that much will be printed and the rest will be left. What I mean to say is, for example, this 300, when it is stored in 2 bytes or 16 bits, it becomes something like 6. Okay, let's say something like this, something like this. When it will be converted to byte, it will only store this value will be stored. Entire this part will be lost. So whatever, these values are not accurate. Just to give an example, I showed them. So this is what happens in explicit and implicit typecasting. Thank you. We'll see in the next video for control statements in Java. Thank you.